in this another video where I've taken questions related to surface area and volume of solids. Now, under this heading, the solids that are involved over here is cube, cuboid and cylinder. So we'll be doing questions related to cube, cuboid and cylinder. So my first question for this video will be, the perimeter of the floor of a drawing room is 66 meter. If the height of the room is 5.2 meter, what is the area of the four walls of this room? Now, children, see, if they are talking about the floor, then we are going to consider it that the floor of this drawing room is in the shape of a rectangle. And when they are saying that the perimeter of this floor is given to us as 66 meter, then we are going to use the formula that we use for finding out the perimeter of a rectangle. So I've taken the same formula of perimeter of a rectangle and I've shown it as the perimeter of a floor, which is equal to twice of length plus breadth. So since the perimeter of the floor is given as 66 meter, I'm going to substitute that value 66 meter is equal to 2 into length plus breadth. On cross multiplying, it will be 66 meter upon 2 is equal to length plus breadth, and on cancellation you will be getting this equation, length plus breadth is equal to 33 meter. Now what is the need of finding out this sum of length plus breadth or this equation of length plus breadth? The reason for this is that the formula for finding out the area of the four walls of the room is area of four walls is equal to twice of length plus breadth into height. Now as per to this formula, you can see the terms length plus breadth is coming. So we are going to use the previous value of length plus breadth in this formula to find out the area of the four walls. Now area of the four walls, remember children, that this is the area of all the walls of any room excluding the floor and excluding the roof. So if we have to find out the area of the four walls, this is a direct formula. And in this, when you are going to substitute the value of length plus breadth as 33 meter and the other values of height as 5.2 meter, and on multiplying it by 2, you will be getting the area as 343.2 meter square. In this way, you can get the area of the four walls. In one more question, where it is given the total surface area of a cubical box is 486 centimeter square. So there is a cube that is given to us. It's in this shape, and they have given us the total surface area. Now this cube has got 6 surfaces, 1, 2, 3, 4, 5 and 6 at the bottom. So the entire surface area means, the total surface area means the area of all the 6 surfaces, which is given as 486 centimeter square. And we have to find out the length of an edge of this box. Now edge means you have to find out any one side. Now children, remember that a cubical box means it's in the shape of a cube, and a cube has got all the sides equal. So if we use the formula of total surface area of a cube, which says it is equal to 6a square, and on substituting the value of total surface area as 486 centimeter square equal to 6a square, the equation will change on substituting the value. And then after that, on cross multiplying, it will be 486 centimeter square divided by 6, which on cancellation will give us the equation as 81 centimeter square is equal to a square. Now because we have to find out the value of a, which is used as to find out the length of any one side of this cube, we are going to remove this square power on the other side of this value. We are going to place the square root sign. So now the equation will change as a is equal to under root 81 centimeter square, and we all know that if you are going to take out the square root of 81, you will be getting the value as 9 centimeters. So that means the length of an edge of this cubical box is how much? It is 9 centimeter. In this one more question, where it is related to cuboid and cube in both the ways, it's a mixed question. As it is given, a cardboard carton is 60 centimeter long, 30 centimeter broad and 30 centimeter high. That means the length, breadth and height of a cardboard box is given to us. How many cubes each of edge 5 centimeter can be placed inside this carton to fill it? Now in these kind of questions where we have to find out the number of any quantity that can be placed in another bigger dimension, So there is a shortcut for that, and that is number of cubes in a carton that can be filled in that carton will be equal to volume of the cuboid upon volume of one cube. Now the shortcut over here is that whenever we have to place a certain quantity inside another bigger dimensional box, you can say, or chest, you can say, then in that case, in the numerator part, the bigger quantity, the dimensions of that bigger quantity which will yield the volume, that we place it in the numerator part, and the objects that has to be placed inside that bigger dimensional box or chest, that volume of a single body, of a single three-dimensional shape, that we substituted in the denominator part. So volume of a cuboid, as we know, the length, breadth and height is given, so it will be 60 centimeter length into breadth, that is 30 centimeter, into height, that is 30 centimeter, upon volume of a cube. Volume of a cube can be taken out by cubing up the side. So if one side is given as 5 centimeter, it will be 5 centimeter into 5 centimeter into 5 centimeter. On cancelling the terms, you can see I am getting 12, 6 and 6. So which on multiplying, we will be getting the answer as 432. That means 432 cubes, each which is having an edge of 5 centimeter, can be placed inside that cardboard carton which is having this as the dimension. So in this way, 432 cubes will be the answer.